histone molecules. These are called histone molecules. So if you have nucleosome, and here are the histones, if you have packaging DNA, let's see what this one, I need to talk about
Several levels of DNA packing make up the compact chromosome seen in the metaphase cell. Even when a cell is not dividing, some of the DNA is folded tightly. The degree of DNA packing makes certain genes available or unavailable for transcription. Chromosomes consist of loops of supercoils, which are made up of tight helical fibers. These fibers are composed of nucleosomes, which consist of DNA wrapped around protein molecules. In the fiber, the DNA is unavailable for transcription. Each nucleosome is a cluster of proteins called histones. Nucleosomes change shape and position to allow RNA polymerases to move along the DNA and read the genes. Chemical modification of DNA in histones may affect chromatin structure and access to specific genes.
Yeah. Video cartoon stick and model of nucleosomal parent. That's what you're going to do, the model of stick and model. Okay, that's the two terminologies here I'm hoping you would know. It's eochromatin and heterochromatin. Eochromatin is loosely packaged chromatin is called eochromatin. Heterochromatin is a very condensed type of chromosomes material. So I'm glad this is being covered. Between these two, between heterochromatin and eochromatin, do you guys read the definition? Which one you think is easier to open up and duplicate? Eochromatin. They're loosely packed. Later on, when we talk about gene expression, making protein molecules based on DNA, the heterochromatin is tough. And that's the last sentence here. It says, it is tough to make genes that are in heterochromatin, very rare. Genes are very tough to express themselves if they are in heterochromatin. Is there any question? No? Okay. Yes?
So it was mentioned in the slide that when a DNA is damaged, when you said damage, it's the mutation, and then you have to proofread it with the...
No, if DNA is damaged, if DNA is damaged, so for example you have a damaged DNA, A, C, G, T, what will happen, a enzyme called nuclease comes and take that segment out. Okay, removes, it cuts and removes that segment. And then DNA polymerase comes and put A to T, G to C in place. Okay, that is the case if the DNA is damaged by sun exposure, chemicals, what have you. Am I making some sense? However, there is another thing, the mutation that I'm talking about. Of course, it can put A to C. Originally, this original DNA was C to G. That's a mutation. Right there, that's a mutation. If this one was G to C, and now it's A to T, that's mutation. And you will see the effect of mutation in next chapter. You will see it. However, when DNA is duplicating, remember, original DNA, half of parent DNA, half of parent DNA. The parent DNA here was T to A, right? In parent DNA, it was T to A. So in new strand, you have T to A, but in this new strand, you have C to G, because there was a mistake right here. The mistake here was T to C. DNA polymerase comes see the mistake and say, this is G. DNA polymerase does not know the parent DNA was T to A. Am I making some sense? A little bit? So That is mutation now. Of course, this is mutation if the nuclease, damaged DNA takes it out. So, two different things. Damaged DNA, or when DNA is duplicating and the new one is formed, there is mistaken new one, the DNA polymerase fixes it. Okay, 5 minutes break. Is that right, guys? Be back here so we can start on chapter 17 a little bit, and then we call it off chapter 17. I made changes. This is not fair. This is not right. I made changes to these PowerPoints, like those slides, and then still I don't get those changes. I don't know what happened. It's all Brian's fault. He sabotaged. He sabotaged mine. Get up, stretch your legs. If you need to go to the restroom, do it now.